The answer to the problem is that it's going to depend on both the shape of the utility and the shape of the cost functions. And here is a very easy way of seeing why this is the case. So suppose that you have two individuals that I'm going to plot side to side, two consumers, 1 and 2. And let's say that this one has a marginal benefit function that looks like this. Sorry, let me just, it keeps going to 0, but it starts high. And this one starts low and goes to 0 at a flatter rate. And now let's look at the aggregate marginal benefit function that is going to look, let's say, something like this. This is the marginal benefit for 1, the marginal benefit for 2. And now let's plot let's assume, for example, that we have a cost function that looks like this, mu of q squared. So that means that the aggregate cost function is going to be a line like this. This is the aggregate marginal cost curve. Now, if this line is very steep, let's say here, so if the line happens to be very steep, we have that the quantity star is here, and at that marginal cost at the optimal quantity, only individual one gets a positive amount. However, in contrast, suppose that this line of production is very flat. So we are in a point like this. So this is the quantity optimal in that particular case when the AMC is there. Then at that particular case, the marginal benefit and cost at the optimum is this. And in this particular case, both get positive amounts. Now, clearly that shows that the cost function matters. What about the benefit function? Well, it's obvious that the example really depends on this marginal benefit curve being much below the 1 for 1. If we were to shift this one or make it the same, then both of them will always get, for these examples, in equilibrium. So it depends on both, at the Pareto optimum, sorry. So it really depends on both.